on the screen. Okay, so the plan for today is to go over anything we need to about advanced ABC, that quiz, and or maybe one or two problems if there are requests, or if I see something I say, hey, we haven't really tried much of that in class, and then move on to chapter 6. So 6-1 is available already. 6-2 will be available soon. I made some progress just today. I think it's getting pretty close. So and then that'll snowball. I think 6-3 and 6-4 will be available well before we're near time to start those weeks. And let's do a little bit. The one thing I want to say is not as relevant to the people in the in-person class here. I don't think that many of you have access to the videos. Maybe you have to check something. That's great. I realized I feel like it's late, a month into the semester almost. I realized that I should change how I'm uploading them because the online class might be more interested in it being very quickly done on Thursday or sooner done on Thursday. I can cut some time out of how quickly I can upload it to the online class by this one change in the procedure. So when it saves from Panopto here, I can assign it to a folder and have a folder per class. And once it's assigned to the folder, it automatically goes to the Panopto video link here for that class. And then what happens is that process takes a while for it to render and to do all its processing. And I usually I've traveled home by that point, away from campus. And when I get there, I download the video and I have to upload it manually to the other folder and to the YouTube channel. And then it has that process of rendering and processing that it does all over again. So it's a little delayed, the second class that it goes to. So starting on Tuesday, I said, what I can do is I can just assign it initially to the online class and have and manually save ours. So if you are reviewing for some reason right after attending class here, the video, you will notice them arrive, the in-person class here, you guys will notice them arrive to the Panopto folder a few hours later than they have been. Again, I don't think it's terribly important for you all, but if the online class is watching this, then they'll say, oh, hey, it's going to be a few hours earlier for us compared to where it was. I thought I was pretty cool to figure that out later than I could have, but this is the first time I've used Panopto Video to do things, so some of the kinks are still getting worked out. Let's attack this quiz then. So 5-2, Advanced ABC. It's our second day looking at it. We have some, looks like we have a very comprehensive job. I skipped this question, I think, or something like this. I skipped a comprehensive question last time we were trying it. Yeah, go ahead. Yeah, go for it.
A, B, C, D, E, F, G.
Mm-hmm.
And then it asks for what is the new activity rate for cost B.
Okay. Yeah, that's another style of the open answer approximated ABC question. Yeah. Let's look at that. I'll do a new poll. I'll pull a new quiz here. Try and get that question or something similar.
Yeah.
Okay, so this is almost it. This is asking just for the cost pool. Yours has parentheses behind each of the cost pools, which is the driver. And that's going to be the difference between the problem we went over last time and the problem you're asking for now. So let's try and find one of those. There, kind of like this one. Okay, so this problem here uses approximated ABC. Just want me to go through the whole thing? Is that good?
Yeah, that's fine.
Okay. You're probably having, your question probably is very specific to getting the activity rate compared to getting the activity cost pool at the very end there. But just as a quick mental rep in case it helps anybody who has a question about the first part, let's go through the whole thing here. And I don't think it'll take terribly long. So we have A, B, C, D, E, F, G. So we have approx ABC question to rate. Okay, and we have, let's see if I can copy these over. We have all of our initial values for the cost pools here. Now, I'm not going to copy over all of the drivers. That's what's in parentheses, the budgeted driver amounts. So in case you're not sure what I mean, what we're talking about when I say that, I got off somewhere. I skipped D. So for example, if cost pool D here uses direct labor hours as its driver, we're anticipating 228 direct labor hours. That's what this is meant. All right, now I'm going to do high dollar cost pools. I'm going to set it up a little differently. So I don't think it'll take too long. No, I just want to say high dollar. Okay, just pulling over the ones I identified as high dollar cost pools because A and D are clearly the largest by an order of magnitude almost above everything else. A definitely by an order of magnitude. This almost by an order of magnitude, meaning like one place value over times 10 the other ones. And then I'm going to take that formula and reverse it and say All right, so now if it's true that there's an X there, which was my indicator for it being high dollar, I want to say nothing. And if there's not an X there, I want it to put the value here. I have too many commas. Now I have the low dollar amounts. All right, I can sum all of these and these. So now I have the total high dollar cost pools. I put A and D here into the total high dollar, and I've taken all the others and put them into the low dollar cost pool here. And I can get percentages now for of the high dollar cost pool here of 350,000 almost, 58% of it, 59% of it is cost pool A. So it should get 59% of this 62,000 low dollar cost pool. And 41% of it is cost pool D. It's of the high dollar ones, only 41% is from cost pool D. And so it's going to get 41% of the low dollar cost pools. They're going to divide among themselves the kill, if you will. So what that means, I'm going to take that percent, multiply it by that sum there, make it absolute. So this is probably not yet where you have the question. You can get this part doing what we did on Tuesday. Okay, so now we're here, and it's asking for, this one's asking for D. Is yours asking for D as well? Okay, so we're looking at D here. And we have now the cost pool amount. So it has its original $143,760 that through first stage allocation, we decided that's what cost pool D, that's what belongs in cost pool D using the percentage weight table and everything. We've summed the column, and now this is cost pool D. And then we've added on, cost pool D also is going to consume, we're going to glob onto it 41% of the low dollar cost pools because we don't want to track those drivers. That's too costly to track. We're not getting enough informational value from those drivers to justify spending the money to track them. So we're just going to push 41% of the 62,000 low dollar cost pool dollars into cost pool D. So we can just track two drivers for these two cost pools. All right, anyway, so that results in $169,493 in cost pool D now. And to form an activity rate, we're going to take that cost pool in the numerator and in the denominator put the driver, the estimated total for the driver, budgeted driver amounts that are in parentheses here. So we would put 141 as the denominator for cost pool A if we were doing it. In fact, I'll do it just for completeness. 141, and we have budgeted driver. And budgeted driver for D here is 228. So our rate is going to be simply the division of these these two. So for each unit of cost pool of the driver associated with cost pool A, we're going to charge a product $1,700 basically. Now the question is asking for D here, so in this case we're going to charge $743.39. That's the answer for each unit of consumption of the cost driver associated with D. Is that making sense? Okay. Good. Other questions on this style of problem? Yeah.
Is it always going to be A and D? Do you ever set up the lowest two highest?
Yeah. It's just the easiest to set the open answer. Certain things I keep constant so that I know Canvas will be able to comprehend the things I'm moving. Yeah, I can't get too complex with the programming of these kinds of questions. I would love it to be where I could say, hey, if it's like this, do this. Like I want to program it like I'm teaching it how to do the actual stuff, but there are limits to that. So yeah, A and D end up being I think in all of them. Yeah. Yeah.
Well, I guess you are showing it, but
This right here?
yeah. So, the answer for this question would be
Yes, this right here is what I would copy and put in. I have to get rid of space and the dollar sign. Yeah.
Why did you use the budget driver for just A and for just D as opposed to like figuring out like the distribution of the driver from B, C, D, and E?
So the reason is that's kind of the punchline of what using an approximated ABC system is, to not have to trace those cost drivers. And so we wouldn't, I don't want to include them really at all. Now, or when if I have to update the rate later, I just want to have cost pool A and D and their drivers. And so I guess when I update, I might do a full study again, get all 7 drivers in there and figure out if they still have the same percentages right here when they eat the little ones. But day to day, I just want to have this driver. I want to put this in the denominator because I'm going to be then apportioning out those dollars based on the consumption of just that one driver. Yeah, it's specifically to exclude those drivers. I don't want to include them in the math because I don't want to trace them later. That's the idea. Does that answer the question? I wasn't sure exactly how to phrase it, but it's a good question. I just think I'm clumsy. The answer seems clumsy when I say it. Yeah. Okay. A lot of good questions. I don't know. This is a thought-provoking question. We'll just do a whole quiz of just these questions right here. I think it's how learning actually works. Okay. If I find a comprehensive question like the Nescio problem earlier, there's I think might be the same one or a similar one. I'd like to do that one, and then I also want to do requests. So let me start with other questions you had requests on. Let's get those out first. I want to go over. Curious about. Yeah, Dylan.
I remember one of the sales mix questions that was asking about release profit.
Okay. So we went over one.
Yeah.
This is a different one, huh?
I
Or
think it's very similar, just that my work in Excel gave me the release profit. That's the one that I thought I put. I might have done it wrong. I said there was incorrect. Remember that we had one in class. So you have to go back and fix.
Okay. So here's one. This might have been one we did in class, or does this look like what you have on your screen right now? This is the one?
I had that one on my quiz. I took on Tuesday. That once you fixed it,
It does now. So did you submit it and it marked it wrong? Okay. Did you submit it before Tuesday? It was after. Oh wait, sorry. Yeah, did you pull? Yeah, did you start it before Tuesday or after Tuesday? That's the question, because it'll pull the questions and then keep them. Okay.
I might have just done it.
Which answer did you pick?
4-0 for product 1 and 2 respectively.
Okay. All right, so let's go through it real quick. I think we can do it very, very quickly here by abbreviating one little piece of the puzzle. Okay. Just change things up. I'll put it on this side of there. Multiply that by that. I want the column absolute. No, that's not quite right. This minus that minus the sum of these three. There we go. Okay, so I can now extrapolate from here which of the product mixes will be the best. This question, all right. So we've gone over it. Have gone over it twice now, so it's not like there's some great secrets behind this question or this style of question. To make it a multiple choice question and make it one that you could reasonably complete in the amount of time that corresponds to the points it would be worth on the quiz and on the exam, I can't make it the way these questions really work out in practice, which is where there's some sort of a constraint which limits you from doing a 4-0 or a 0-4 that makes it so you have to balance the two. Because it's set up the way it is, one product is just predominating the other one. So it's always going to be most profitable to just do all of that one product, and least profitable to be all of the less profitable one. So product 1 here earns $26,000 per pop. It's most profitable. It's just $5,000. It's $7,000 more profitable than product 2 every single time we sell. And so if we're going to choose a mix, the most profitable is always going to be 4-0, 1-2. And the least probable is always going to be 0-4. Well, you said you did 4-0, and I think you just got it flipped around in your head, or my weird phrasing of the question didn't come through. You're like, obviously, which is good instinct. Obviously, they want to maximize the profit, so why would they be looking at least profitable? Okay, that was what it was. So that's kind of the inside baseball secret of this multiple choice question here. There's no way I can do a 3-1 or a 1-3 being most profitable, given the fact that I haven't added the complexity that would make this question need to be worth more points. So, unless I'm going to create a second section of this test bank which has these longer questions that you have to work out a little bit further. At least I didn't see a way when I was creating the question. Yeah. Gotcha. Okay. Okay. I in case you're this is looking very foreign to you. We went over it the other day, but we got revenues here for the two products. Their direct costs right here, and then I have their consumption of the three drivers, the three activity drivers, and which are the words here, not the numbers here. And then I have those numbers right here for the respective drivers, and I've multiplied them. So these are dollar amounts, and these are dollar amounts, leading to these being dollar amounts. If that helps it be clearer what's going on in this. Okay. Yeah, I already knew the activity-based management would be stretching the bounds of these questions would be stretching the bounds of work to points trade-off there, because they move towards being a separate case and looking through all the different scenarios and whatnot. Being a case study is what I meant to say. All right. Okay. Yeah, I'm remembering going over this at some point. No, not this semester, but yes. We're trying to figure out the optimal profit given the fact that we have to say goodbye to one of them, right? So, wait, did I say that wrong? Yes, there it is. All right, so we're an accounting firm. We use activity-based costing. The firm has to drop one of the following 3 customers, which consume the following activities. I don't know what the backstory is. We got to drop one. They don't like each other. I don't know. Something weird. But we have to drop one. And that creates the predicate for a multiple choice question in this weird scenario. All right, so what we're going to do is we're going to figure out the cost of each of these based on the direct costs and their consumption of the 3 drivers that we have. We also have to figure out what that means in context by taking the activity-based costing pool information here and creating rates, which isn't too hard. We have the cost pools already figured out. That's first stage allocation. I'm just going to divide those by the activity drivers, to get the activity rates over here. If I were in Excel, I'd be this divided by this to get a new cell over here. That's the activity rate for each of those 3. Multiply those rates by their consumption of these to get the overall cost for the 3. And down here we have what they're contracted to pay. I just separated out the revenue. So let's look. What we're going to do is we're going to figure out each one, how profitable each one is. And then what we'll say is we'll just sum the 2 most profitable ones because we're going to drop the ones least profitable. All right, so we have XYZ customer profitability analysis. Got over somehow. X, Y, and Z. And I'm going to go ahead and put the revenue up at top. Just going to grab it from here. $650,000 for Xavier. Young, 1 million. That's 100,000. And Xavier is 750,000. Zane's, sorry, is 750,000. Let's put that in dollars. Get rid of the. Okay, yeah. Make sure I got the right number of zeros in there. And we have direct costs. I'll go back up here now. We have $10,000 in direct costs for Xavier, $50,000 for Young, and $25,000 for Zane's. And then we have their consumption, 120, 250, 110 for partner hours, 10 filings, 15 filings, 17 filings, 100 interview hours, 350 interview hours, 250 interview hours. We have the different rates. We don't have the different rates yet. Let's see if I can copy it over. Let's do that over here. Good. Okay, I'm going to see if this will divide. No, still doesn't do it. No, I was hoping that the clean business would help with that, but it's too dirty. Okay, we have some 3 rates here now. 1562.5 for each partner hour consumed, 1250 for each filing, and 250 for each interview hour. All right, I'm going to point to those right here. No, not that one. Go far enough over. All right, and I want to grab the consumption of partner hours times the rate for partner hours, make the column absolute. Go to the right, go down, Control R, Control D, and I think that's working right. Yeah, looks good to me. Okay. So now I can take the revenue, minus the sum of all the costs. We have direct costs, and we have our overhead costs from the 3 cost drivers. Yeah, I never like to close those parentheses. It always gets mad at me. So let me make sure I haven't copied something down wrong. Let me look at it here for a second, or you can point out to me if you see something I'm doing wrong that I haven't caught yet. Copy these over. I copied those over. Good. And those are copied right. Yeah. These calculated right, I think. I don't know what. I don't need to clean anymore because I cleaned it manually. Yep. I think those should all be right. Copy them over. Okay. So it looks to me like the least profitable is the Xavier customer here. $415,000 from that account compared to $453,000, $125,000, and $469,000, $375,000 over here. So what we can do is we can sum those two. So that one should be the right answer for this one, $922,250. So this question stem, maybe it's incomplete in the sense that I'm saying what's the optimal profit that can be earned from these customers, given that we have to drop one. Given the fact pattern in this question, which we have to drop one. The optimal profit is going to be determined by us being the optimal choice of which one to drop, which is determined by us having a clear picture of their cost that they cost us, which comes to us from ABC, hence the point of this question. Yep. So you guys, an interesting question, an interesting point there. So you're saying that we're anticipating 320, we have 320 partner hours, and these two to combine equal more than that. I wasn't intending that to be the nature of the question, but that is something that would be important to address. Now, that said, technically speaking, this is their prior consumption or whatever. What they've cost us is the idea. They consumed the following activities in the past, and we're anticipating 320 partner hours in next period. So I'm going to wriggle out of that one by technicality, but you raise a very valid point. So maybe I should change the number so that isn't even a question. Yeah, Elton. It's supposed to get rid of, I thought, a number of things like leading spaces and trailing spaces. It didn't work on this particular cell. I'd have to look into it a little bit closer. Yeah, that's my understanding. Removes all non-printable characters from text. So maybe the spaces weren't considered non-printable or something. I don't know exactly what the problem was. I'm not in the habit of using it that much, but I've learned about it recently, so it's my new toy. Trying to figure it out. Okay.
Can I see how you got the final line?
This right here? Oh, the line. Yeah. So I'll go to this one. I took the revenue minus direct costs and minus all the overhead costs, the sum of those 3 lines of overhead cost. I think last time I set a problem up that was like this, where we're trying to figure out the profitability of, I think it was when I did on Tuesday, don't do that. On Tuesday when I did this kind of problem, the profitability of these, I put subtotals of the costs, and so that made it clearer, I think, what I was doing in that line. But okay. Gotcha. Okay. The questions we've got. Just making sure I don't forget. All right. Other questions you want to see from that? Yeah, Garrett. Bubba. Oh, it's right here. Well, a version of it at least. Good one. Okay, another activity-based management one where we have to kind of model the whole scenario. You just want to go through the whole thing? Okay, good. All right, so Bubba's Custom Shrimp Catering uses activity-based costing to determine the cost of its catering events. The firm has 2 activity cost pools, cooking, which has an activity rate of $500 per catering event. Okay, so per catering event, we're going to be playing a little bit with what ABC can do, and it can allocate costs at different levels of the firm more easily than other costing systems. So it can charge per catering event $500, very, very simply. And the other activity cost pool is for serving, an activity rate of $12 per plate. So we have events and plate, those are 2 cost drivers, and we charge them at $500 and $12 based on these 2 cost pools and rates. So the firm currently has 25 catering events a year with an average of 50 plates per event. So now we can figure out a total number of events, 25, and 25 times 50 should be our total plates we have each year. We also incur $400 of direct costs for each event. So $400 times 25 will give us the direct costs that we're going to be also needing to factor in. We might need to factor in anyway. The firm has 4 opportunities to improve its processes listed below in the answer choices. These are the 4. None of them are expected to affect revenue. Each process improvement costs $2,500. Which of the following is the most profitable process improvement? So let's model this out here. So they earn some revenue of some kind. We're going to leave it blank. So what we're doing, we need to make sure, before I go any further, I'm going to make sure I'm doing, this is a cost-only analysis. So I want the lowest amount of cost. I don't want to get myself turned around here and try to maximize cost. Because I don't have any revenues given to me. I don't know what the revenues are. Each process improvement doesn't affect revenue. We're just trying to minimize cost here. All right. So we have 25 events per year. Do it that way. We have 50 plates per event, which means we have 1,250 plates per year. We also have $400. That's direct costs per event. So we can also do a multiplication right there. 25 events times $400. We have $10,000 of direct costs per year. And so we are incurring, we have these 2 rates here as well. We have 500, that's overhead per event based on this rate right here. And we have $12 overhead cost per plate. That's the charge we're charging overhead to each plate. So we have 25 events per year, $500 overhead per event. $12,500 is the overhead per the event overhead per year. So I'm trying to get total cost per year. I'm going to get these 3. And then we have our overhead per plate times the number of plates per year. And that is plate overhead per year. This is the total overhead we're expecting to based on the serving activity. So I can put that as well. I could change that if I want. Let's do cooking and serving. Those are the 2 activities that these represent. All right, so total costs, I'll put it here. Total cost is the sum of our direct costs, our cooking costs, and our serving costs. So $37,500 is where we start from. I'm actually going to flip these. That's where we start. The status quo is 37,500. Okay, so now we could reduce direct costs per event by 25%. First option. 400 reduced by 25% is going to be 300. A quarter of 400 is 100, so now it's only $300 per event. Okay, is that all right? Our total cost is $3,500. Looks like that improvement saves us $2,500 from the status quo, which oddly enough is actually how much that improvement would cost us. Each of the improvements cost us $2,500. So it breaks even. Congratulations, improvement number 1. Doesn't actually save us anything because it just barely breaks even. I bet the others will save us more. Second, reduce the number of plates per event by 20%. Okay, my alarm bells are going off. The professor's creating questions, trying to make sure there's only one right answer per question for the 4 distractors, the 4 possible answer choices. 20% is lower than the others. So I wonder if number of plates, which is the amount of consumption of the driver, and the rate, which is how much we charge per driver, is associated with that, which is the serving activity. I wonder if he made those percents different because he wants to make number 4 most profitable. All right, reduce plate usage by 20%. All right, good. We started from status quo. We had 400. Didn't change that. I properly copied from status quo instead of from number 1. Reduce plate usage. Okay, here we go. So 20% or 1/5 of 50 is 10. So we're taking away 10 plates per event. I'm not sure how we're doing that and not affecting revenue. Just eat with your hands. 40 plates per event. Saves us, it's $500 more than option 1, which means $500 in the black for the overall improvement. It's going to save us, it's going to be profitable to the tune of $500. The original was $37,500 down to $34,500. That's $3,000 of savings. It costs us $2,500 to get that savings. Okay, that's all I was saying. Grab the status quo. Let's look at option 3. All right, reduce cooking activity rate by 25%. Okay. I copied everything right, looks like. The activity rate for cooking. Now, the cooking is the per event. Yeah, $500 per catering event for the cooking activity. So 25%. 25% of 500 should give us 375 if I got my math right here. I'll do my... Yes. So, sorry, 25% less of 500 gives us 375. Okay. I've done it a few times. It's my weird way of doing this. Questions on what I did just there? Okay. Just don't want to leave anybody behind here. Looks like we saved even more here than we did here. We have now gotten down to $3,125, $31.25 in savings. Good. Let's go back to status quo one more time. And look at number 4, which is one that my radar went up on as maybe the right answer. Reduce serving activity rate by 25%. So the rate here for serving, $12 per plate. So that should give us $9 per plate. And that is indeed the most savings, so the lowest total cost. Yeah. Yeah. I mean, it's important in terms of if they were actually going to do it, make sure it breaks even and is actually worth more than it costs. Yep, you have to choose one. They all cost $2,500. So of the 4 answer choices, it's not differential. Like in chapter 2, it doesn't differ between alternatives. So it's important in practice, but it's important to actually implement.
Like if we have revenue.
It's important to choose. It would be important if none of them broke 2,500, because then we have a second choice. Do we make a process improvement of these 4? No. We have that decision tree. Make a process improvement of those on our plate of possible ones. Yes or no. And if we do yes, which one? 1, 2, 3, 4, which is what we're doing right now. And if none of them broke past 2,500, then the right answer would be don't make any of those process improvements. They're process deprovements, whatever, disimprovements. Okay, so this is the most profitable one right here. Right? Does that help with Bubba's? Okay. All right, any other requests? Don't say Piano Man. Oh man, I kind of thought that was a little bit of a decent joke. All right. Well, going once, we're going to move on to chapter 6. This one right here, set 9. Okay. A hospital uses time-driven activity-based costing. So TD-ABC question. The nursing department has the following overhead costs. So I've listed and said these are all overhead costs in the question. So these are for our overhead costs, these categories. The department has 2,180, has 2,180 nursing hours per period. What is the department's capacity cost rate? All right. Actually, let me give you 30 seconds to a minute to try to solve this problem. And I will pull the Excel over to the other side and work on it over here. Let's do that. All right, anybody get an answer for this one? So, what'd you get? 15.11. You omitting the nurses' salaries here? Okay. So taking these 3 in the numerator, summing them and putting them in the numerator, and then dividing by 2,180. Okay. The procedure's right, except in this case, you include the nurses' salaries in overhead in the numerator there. I don't have that sentence that says it's traced directly to patients. There's another version of the question that has that, in which case you omit nurse salaries, and I think also medicine costs in that other version of the question we did the other day. So if you include it in there, you should get, if you put in that 53,456 in the numerator, I'm getting 39.63. 39.63. Okay, good. Then your procedure's just right there. Great. Hates me. There we go. All right, good. And yeah, so that's the capacity cost rate, and then we would take the capacity cost rate, multiply it by whatever the study decides is how many nurse hours, just like in this question, similar to this question, are consumed per each of the activities we're interested in following. And now we have activity rates for those different activities based on their consumption of the constrained resource here. Oh, let me pull over the spreadsheet. That's all I did. I took Took the 4 categories. I summed them to total overhead costs. It's the numerator. I pulled in 2180. That's the nursing hours denominator. And we have the capacity cost rate at the bottom. It's just a division of those two. Yes, this one's a more comprehensive TD-ABC where you find the capacity cost rate and then multiply to get an activity rate. You want to go over it? Okay. So this one, we can do it pretty quickly here. Copy over the 3. I think this is faster than me typing it. I might be wrong. And then we have 1867 as our, not it's a number. That is our technician hours. So I'm going to take the sum of the overhead costs. It says those 3 types these 3 numbers are the overhead cost categories. That's the numerator, total overhead cost, and divide it by our technician hours. That's our constrained practical capacity number that we're given, the expert. Right. So our CCR then is 8.75 and a bunch of trailing numbers. I'll leave it like that for now, so because Excel can handle all that complexity. All right, I'm going to type in 1.48. Wait. What's the question, Simpson? It says, what is the department's activity rate for the activity cost pool that uses direct labor hours as a driver? So I really only need to know this one right here times the capacity cost rate. It's almost costless, though, to do all of them, so I'll just do all of them just for fun. I say just for fun. Okay, make that absolute. So I'm taking the CCR, multiplying it by each one. So this bottom one is the answer that we're looking for, rounded to the nearest cent. So 17.43 should be the dollars we're going to charge every direct labor hour that is consumed. And that's just overhead on top of any direct labor that is directly charged to that job or that whatever they do in this firm. They have technicians, so is it a mechanic shop? Is it I don't know. Maybe they inspect something. Technicians are inspecting things. Good. Okay. I'm going to push submit here. Let's see, we have 4 questions we answered. No, I get all of them right. Unanswered. Right. Unanswered, right, and right. Good, okay. 14's throwing me off. Oh, these open answer are worth more. That's why. 2 open answer worth 8 plus 2 multiple choice worth 3 each. All right, so let's jump into chapter 6. So next week's module is starting chapter 6, and we are breaking it up this way. There are 2 big types of process costing. There's weighted average and FIFO. And weighted average is the procedure is simpler. We'll get into why and how much simpler later. But it's a little simpler, so we go over that first. 2 weeks of weighted average. And then we'll go through the same thing we did with weighted average, but now with the FIFO method. And those are the 2 we go over. We don't go over any LIFO or anything like that with process costing here. The way we split it up across the 2 weeks is there are basically 3 things we're doing. We are calculating total equivalent units, TEU. That's an important calculation. We are using that TEU to develop a rate or multiple rates. And that's the second kind of stage of the process of process costing. And then lastly, we're using those rates to apply costs to ending work in process and units completed and transferred out. So what we're going to do is the first week of weighted average and the first week of FIFO, we go over these two. The questions are about these two right here. The second week of each method, we go over applying costs. I want to give FIFO applying costs its own week and quiz because there are a few wrinkles there that if we go over quickly, we're just going to roll over everybody. It's not fun. So let's talk about process costing more theoretically and generally, and then talk a little about what we do with the weighted average procedure here. So I have my fun GIF here with the idea of seeing if you can count how many times the gears turn. Anybody know how many times the gears turn? The correct answer is once. It's just repeated. I looped it almost right. You can just barely see, I think, it's this one right here. It kind of hesitates and goes back a tiny bit. That's as close as I could get to it being continuous. You can most easily see the break in the loop right on this gear right here. Sorry, nobody wins a car this year either. So I'll keep trying. So, best way to kind of introduce the idea is with Chapter 4, job order costing, which we went over very briefly just to review, and then Chapter 5 with activity-based costing, which we've spent 2 weeks on now. We're doing a lot of tracing. We're tracing all the direct costs, of course, because they're highly traceable and they're direct. So obviously we'd want to know how much direct material and direct labor costs each product is incurring so we can know how much it costs us so we can determine if it's profitable. And then we're tracing some sort of driver or drivers, in the case of activity-based costing, to figure out how much overhead each of those products is responsible for and therefore determine its profitability based on, or use that to help determine its profitability. To kind of, I don't know, sound like a punk band, why bother? You know, that's a lot of work. And in fact, sometimes in business, it's not worth it to do any of the tracing. I mean, let's say, I know this is a big happening area now. Everyone's into it. Let's say you're a marble manufacturer. Yeah, that was me being sarcastic. Yeah, I don't think marbles are making a comeback anytime soon. But let's say you're a marble manufacturer, not Marvel, although there's a joke in there about it being mass-produced as well. But marble, M-A-R-B-L-E, and you produce like 1 million identical marbles every week, day. I don't know, a lot. You could make. Depending on how popular marbles are, they're identical, and you're mass-producing them, and you probably make a lot of them. So this continuous process of probably heating up the material, the glass material, so it's a mixture of sand and other such stuff. I haven't made glass, so I don't know for sure. I do drive by that glass blowing place, though, on Chinden on the way into work. So maybe I'll someday learn what's made into glass. But anyway, you take the raw materials for glass, heat it up, and make it into little balls, and make sure that they're circular. And that's about it. Probably some design stuff, but you're gonna have the same design stuff for a bunch of marbles. My point is if you went in, if you or a worker went in there and started taking one marble at a time and naming them and singing songs to them before they go to bed at night and deciding, oh, I'm going to trace exactly how many microseconds I spent on this marble, and that's crazy. Don't do that. That would not work. At least that's crazy from a business perspective. You wouldn't want to do that. That's unprofitable. You would be paying people to do this ridiculous thing that offers no value. And so basically the idea is in some manufacturing environments, we don't want to go the way of more precision in how much each unit is responsible for. We need to go in the direction of how simple can we make the process of assigning costs. And although it's not simple to learn necessarily all the techniques and whatever, you might think over the next 4 weeks, this is simpler. If you're repeating this process over and over and over again in the company, it's much simpler than tracing individual products or jobs or orders, consumption of direct materials, direct labor, and overhead drivers. So we start, I think I like the way I introduced this chapter, so I'm going to kind of go through the logic of the chapter here. So it starts innocently enough. Look, there's the easiest way to look at overhead cost is simply to say, well, we could just divide it by units. Forget drivers. We could not try to trace any drivers. We could take total overhead cost and divide it by the number of units, and just every unit gets charged its fair share, just a per capita, per head cost of overhead. This is not an equation that you're going to use, but it's just kind of working through the logic of how you go from, say, a job order costing environment to a process costing environment logically. So yeah, okay, well, great. We have an overhead cost per unit. We have cut out tracing any drivers. The first complication that arises here is the fact that we have some units in an ending work in process. And that's going to be the case when we're in a process costing, mass manufacturing, continuous, and homogeneous, all those words are important in describing, process costing environment, like a marble manufacturing venture, or something like that. We're going to have, at the end of the period, a bunch of units that aren't all complete. So I decided not to do it this semester. I think I can abbreviate it and get the punchline without us risking all the insurance costs that come along with the paper cuts that might arise. But often I've simulated in the past a paper airplane company in the class. I had each person like 5 or 6 pieces of paper. So imagine I've just handed you 5 or 6 pieces of paper, and we're going to, for 30 seconds, I'll put a timer on the board or whatever, we're going to fold paper airplanes. And you're free to fold them however you like. You're free to do whatever you want in terms of folding, but we just have 30 seconds to do it. And we do it. I collect paper airplanes. I count up on the table here. All right, how many are complete? And some of them will not be all the way complete. They'll be partially complete. And that's kind of the story here. We have some that we completed, and they moved on. We'll come back to the paper airplanes in a minute. And some that they're partially complete. So they're ending work in process. If the 30 seconds means the period time, and the end of it means we stopped working on it, or that's midnight on the end of the month, then that means that, hey, those units were not complete. They're in any work in process, and they didn't really have as much work done to them as the completed units. So if we're trying to be accurate without doing a lot of work, we've got to figure out a way in the system to account for the fact that these are partially complete units. And this is how we do it. We stop using units, and we convert units into equivalent units. We're going to act like, let's say there are 4 folds necessary to make a paper airplane. You got 1, you got 2, you got fancy 3 and 4, whatever. Imagine the fancy 3 and 4. And you have a bunch of paper airplanes that have just 1 fold in them. They're like a fourth of the way done, right? You're imagining that you have, let's say, 100 paper airplanes that have just 1 fold in them. Ending Whip has 100 paper airplanes. They're 25% complete. You're acting as if, hey, you know what? If we hadn't spent our time folding 100 paper airplanes with 1 fold, we could have folded 25 paper airplanes with all 4 folds. Those 100 paper airplanes with just 1 of the 4 folds that they need is the equivalent of 25 complete paper airplanes. That's the equivalent unit idea. So we're going to take the percent completion, 25%, times the number of units, 100, or physical units. Sometimes it's called physical units right here to differentiate it. And we end up with 25 equivalent units in ending work in process. Okay, so now, if we were just to continue the logic from before, we could take our total overhead, our total overhead here. Actually, I think I have the equation down here. Yeah, we could take our total overhead and now divide it by equivalent units, total equivalent units we have, times and that would get our overhead cost per equivalent unit. Okay, so now we've factored in the fact that some of our ending WIP isn't complete. And I've also introduced TEU, total equivalent units. So we have all the paper airplanes we completed. Let's say you're very, very industrious and all of you completed 500 paper airplanes. And then in addition, we have 500 actually complete. Units completed. And then we have 100 ending WIP units. That's EWIP units. 25% complete, then our total equivalent units that we did work on is the 500 we actually completed plus the 100 that were in ending WIP times their 25% completion, which equals 525 equivalent units. All right, so you put that in the denominator. Instead of we wouldn't just put 600 because these are not all the way complete. They really would represent the equivalent of 25 complete paper airplanes, given our example here. All right, so we got over that complication. Let's move forward. Next complication, non-uniform consumption of product costs. I know. You all have been spending time up at night worrying about non-uniform consumption of product costs. It's a very common problem, right? What I am saying here is actually very relevant to the paper airplane. So, what goes into a paper airplane? Paper. What's the process of converting a piece of paper into a paper airplane? You fold it. Okay, so what we have is we have a raw material, paper. We convert it with labor and overhead, which would be like our overhead costs would maybe be the insurance costs because we're going to risk paper cuts or whatever. Anyway, with labor and overhead, or the cost for the lights or whatever, the cost for the room here, overhead costs. Anyway, we convert it with direct labor and overhead costs into a finished product. At what point is it complete? Well, sorry. Paper goes into a paper airplane. That's all that goes into it, right? As far as materials. So the moment you start folding, how complete is that paper? Does it have all the paper it's going to need? Yeah. That paper airplane has all the paper it's ever going to need the moment you take it onto the factory floor and start folding it. Is it all the way converted into a finished product yet? No. So we want to create, usually in a factory, in process costing, this is why we teach it this way, and this is usually how companies tend to do it, is they create two tracks with different percents completion. One is the direct materials track, and one is the conversion cost track. So we want to have two different percents completion for ending WIP and ending WIP. Those 100 airplanes that are not done at the end of the period, they're 25%. They had one of their full four folds. So they're 25% complete with respect to conversion. How complete are they with respect to their paper? They've got all their paper, right? They're actually 100% complete. With respect to direct materials. And so this 525 is only the equivalent unit, the total equivalent units with respect to conversion costs. So try to put a little subscript of CC there. If we were to do a TEU for direct materials, it's that 100 units times 100% complete, or 1. And we have 600 equivalent units, that's total equivalent units, I guess, for direct materials. That's non-uniform consumption of product costs. We've consumed the product cost for direct materials at a faster pace. That's often the way at least we explain it, and often it's the case what we do. Faster pace than we consumed the costs, the conversion costs, which is direct labor and overhead that goes into converting the raw material into the finished product. Okay, so now we've got to, let me start from, we jumped from overhead costs in the numerator to now being all product costs in the numerator. Because you know what, if we're not tracing cost drivers, why are we tracing anything at all? We can just get away with taking direct labor and direct materials and acting like they're not direct and not caring. They're no longer direct. We're just going to distribute them on a per capita basis. Every unit gets its allotment of direct materials and direct labor costs. I don't actually care how much direct materials it used or direct labor it used. It's just going to get the average amount because we have 1 million marbles on the factory floor. I'm not going to name each one and figure out what its fraction of a penny of direct materials is or whatever. It's kind of the idea. All right, so yeah, we end up with different total equivalent units, the denominator here, for direct materials and conversion costs. I skipped over something and I'll come back to that in a minute. And Now the idea is we want TEU because we're going to put TEU, total equivalent units, in the denominator, and we're going to put some cost number in the numerator to get a rate so that we can charge each unit its rate or its allotment of that kind of cost. So we have two of them now because we have non-uniform consumption of product costs. We have direct materials rate is based on the direct materials cost in the numerator, and the TEU in the denominator, which in this case is 600. Conversion cost is based on the conversion cost, whatever it is, your labor and overhead it costs us, and then divided by the TEU for conversion costs in the denominator. All right, so now we have two rates. And the third complication really isn't that big of a deal. It's called process costing because we're taking the focus away from tracing costs directly to individual products and towards tracing them to the overall process, and then just gets averaged to however many units went through that process. And process is generally considered synonymous with department. The idea is you have a department that does one process, and then you line them up. You have process A, department A, process B, department B, and process C, department C. And I'm going to use them interchangeably in that regard. If you want to change the terminology in your company, that's fine. It's fine. But for simplicity, we're just going to treat them as synonymous. So we have A, they do one thing. A assembles the different sand or whatever that goes into it. Department B then heats it up. Department C then makes it into the marble balls, and Department D then polishes those and makes sure that they're properly round and quality checks. So they each do something different. Department D, let's say, it gets a molten glass ball from Department C. Or gets, did I describe it that way? Anyway, let's just say it does. It gets something, it gets an input. So it's going to get some transferred in costs, is the idea. You have transfers between departments. And so all the costs that Department A, B, and C have put into it are going to move on to Department D. So what we usually do is we have a separate category of transferred in costs, which is the cost of the material that's being transferred over. It works the same way as if it's like a direct material that you're adding in your department. Its cost is determined by the previous departments, and we use a different rate. We calculate a different rate for it. This really doesn't factor into too many problems or too many elements of the learning process costing and doing process costing. And so I don't want you to focus on this one too much. It'll be there, but once you conquer the other problems, you'll be fine with that one. All right, so I like this illustration a lot. I think I'm gonna finish here, and then we'll pick it up on Tuesday. What are we trying to do with process costing? All right, well, here's a T account. The idea is we know we're charging based on, or we have certain costs we're incurring. This is department work in process inventory account. We have some costs that came over from last period. We have some current period costs. We have to pay people, direct labor. We have to buy materials, direct materials. Those get charged into as debits into the current period costs. We have to pay for all the overhead. Those get charged into as current period costs. And a portion from last period carries over right here. The same kind of things, direct materials, direct labor, and overhead. And if we're not tracing them to individual product units, we're not tracing costs to individual product units, we have to find out, we use process costing to figure out how much gets split between these two. The rates that we develop in step 2 up here are what help us decide how much goes to ending WIP, stays in the department's WIP T account for next period, and how much gets completed and transferred out. That's either to the next department in the chain. If we're Department A, it goes to Department B. Or for the last department in the chain, how much of it gets transferred out to finished goods inventory account. So the concept is going to require a little bit of accounting knowledge, I guess. But the execution doesn't really require any debits or credits. I don't ask for any debits or credits here. But the idea is pretty simple. We have dollar amounts here. We're trying to figure out how much goes to ending WIP and how much goes to completed and transferred out. And this should balance. The amount in the blue should equal the amount that we put in these two right here. We're just deciding how much gets split into each one. And before we get to tale of two methods, I'd like to point out the basic shape of it is this. Oh, that's what I want that right there. I'll rewrite that. We want dollars over total equivalent units to get a rate. We have our WIP dollars. Current period dollars. We're trying to figure out how much are going to be credited out to go to the next department or go to finished goods, and how much goes down here of this right here. And at least in weighted average, very simply, this is our numerator. We'll come back and make sure that we got this concreted, don't worry. And our denominator, total equivalent units, if you remember, it's units completed plus the equivalent units in ending WIP. Lo and behold, the denominator is this right here. So we're going to take the numerator divided by the denominator, then multiply that by the equivalent units in ending WIP and the equivalent units here in units completed to figure out how much of this goes to the 2. It's got its own kind of beauty to it and song that it sings. Just fun to get to know it eventually as we go along. All right, so let's hit this again Tuesday. We'll have plenty of chance to go over problems and maybe some of the things that I say today, or if I give a little lecture on the theory Tuesday, they'll start to click as we get into the problems.